Hello, everyone. I hope that you guys are having a good conference. And to end the technical content on a high note, we have kept one of the most interesting keynote talks at the end. So that is what I have the pleasure of introducing the keynote speaker today. So our next keynote speaker is Anand S. Anand is a co-founder of Graminar, a data science company. He leads a team that tells visual stories from data. He is recognized as India's one of top 10 scientists and is a regular TEDx speaker. Anand is a gold medalist from IIM Bangalore and an alumnus of IIT Madras, London Business School, IBM, Infosys Consulting, Lehman Brothers, and BCG. Probably he ran out of space, otherwise there are probably many more. But Anand is, what is not written here is that Anand is also a very avid reader and an amazing writer of blog posts. He writes some amazing blogs which I happen to follow there. Now, coming to the more interesting part of his bio and more innovative part is where he says that he has hand transcribed every Calvin and Hobbes strip ever. He is addicted to Minecraft thanks to his daughter, and he dreams of watching every film on the IMDb top 250 except The Shining. I don't know if he's going to explain that. But with that, I welcome Anand, and I really thank him for his time today to talk to the Flipkart data science and Flipkart group data science community. So Anand will be talking, and Anand said that he wants to take a couple of pauses in between where he will be looking for some responses and some way, and he will probably explain. So just wanted to mention that. Of course, he will be doing the larger part of the Q&A towards the end of his talk. Okay. Welcome, Anand. Thank you for your time.
Okay, cool. Sorry, if this happens again, then please just let me know. I'll unplug and replug. But I was thanking Shaurya for
So sorry, if
firstly
just
that
put the mic a
introduction.
little closer, sir. What you wearing?
Sure.
Yeah. Yes, much better.
Any better now? And I'll be a
Yes,
little
thank
louder
you.
as well. Yeah, no, thanks for that prompt. No, thanks, Shaurya, among other things, firstly for that great introduction, but also for being the first person to ever ask about the reference to The Shining. And I'm going to take this opportunity seriously to explain that. So I read The Shining in 96 and I couldn't sleep for 3 nights. Literally, I just was worried about what was under my bed. I've also watched a fair number of movies by Jack Nicholson, and he's creepy. You know that, right? And the director of The Shining, well, if you've seen 2001: A Space Odyssey, Arthur Clarke is among the gentlest of science fiction writers. But when he directed 2001, it was a creepy movie. Now, combination of 3 ultra scary people, no thank you. I'm not a horror movie fan, but I am a major movie fan. And I don't know if you, the audience, will get anything about network clusters as a result of this talk. I hope you do. But I'm fairly sure you'll get a hell of a lot about movies. In fact, this whole exploration into networks for me began with movies, specifically from one actor, Govinda. I hadn't heard of him till 2000. And then I saw Bade Miyan Chote Miyan and I said, okay, this is a really interesting guy. I've been following his career for some time. But let me share my screen and show you something that he had mentioned on the news some time ago. He said that he had declined a role in Avatar, James Cameron's Avatar, on Aapki Adalat in world public. So we hypothesized, what if, and this is just a hypothesis, what if Govinda says he's acting with Angelina Jolie in a David Dhawan film titled Jolie Number One? My apologies to people who don't know Govinda or Angelina Jolie or David Dhawan, but this is just a hypothetical scenario. And assume that he says he declines to mention who actually connected him to Angelina Jolie. Now, we begin our fictional detective work. Who might have possibly connected them? Well, it might be one of his heroines. He's acted with several of them, and Neelam is his top heroine, followed by Kimi Katkar, followed by Karishma Kapoor. Sorry, get the list right. Yeah, Ravina, Farah, etc. But have any of these acted in Hollywood? Well, Short answer is no. None of these have Hollywood connections. Okay, it might be one of his male co-stars. If you look at the set of people that he acts with among the male co-stars, Shakti Kapoor tops the list, who's practically his boyfriend with 22 films, followed by Kader Khan, Gulshan Grover, etc. Have any of these people acted in Hollywood? Now, it turns out that there are at least a couple of them who have in fact acted in Hollywood. Gulshan Grover and Anupam Kher have acted in multiple Hollywood films. So that's a possibility. But have either of them acted with Angelina Jolie? That becomes the next question. Now, if we take the network of actors that Angelina Jolie has acted with, Dustin Hoffman, Jack Black, they've all acted multiple times. But there is only one Indian actor, one Bollywood actor in that list, Irfan Khan. So, which means that to get to Angelina Jolie, Govinda must somehow connect to Irfan Khan. Now, Gulshan Grover is a possibility. They have acted together in Knockout. So has Sanjay Dutt. But an even better possibility would be Tabu, who has acted in multiple movies, both with Govinda as well as with Irfan Khan. So, net, Govinda must have connected with Tabu, who must have connected him with Irfan Khan, who would have connected him to Angelina Jolie. And that is how Jolie number one might have come about. Now, this is a hypothetical script, but the way we got to it was, but everything else is real, by the way, that this is pretty much the strongest, or was the strongest path from Govinda to Angelina. And the way we got here was by exploring the Internet Movie Database. Let me show you what it looks like. So the IMDb, which if you are not familiar with, is a database of movies on the internet, and it has data sets that you can download. These data sets are pretty detailed and pretty large. So there's information about each of the person's names, the titles, the crew, the principals, etc. So what we did was took three specific data sets. One, the names of the actors, Fred Astaire, Lauren Bacall, etc., which also has their birth years, death years where applicable, what is their profession, what titles are they known for. Second, the film titles. And these film titles also include the year, the runtime, and a few other pieces of information, like whether they're documentaries or animations and so on. And thirdly, the linkage between these. That is, which title, and tconst is a unique ID for the title, acted with which nconst. Nconst is the name of the actor, a unique ID for the actor, and with other information about what was the role. So what this is saying is title number one had actor number 1588970 credited as themselves. And here was the director of that film. Here was the cinematographer of that film, and so on. So what we did was loaded the data, just downloaded it locally, and then started reading it. Now, these are TSV files. For those of you who are familiar with, I'm just going to happily assume that all of you know pandas, but there's a simple rule of thumb for following technical talks. When anything technical doesn't make sense, just ignore it. The talk will make perfect sense without it. Okay. So we started by reading this data. Now it turns out that there's a bit of an unfortunate glitch. Amazon publishes these gzip files in a way that the Python gzip module can't actually read. It turns out that they need the zlib library. So we worked around it a little bit to handle the data using zlib, but ultimately loaded it using pandas. Now, it's a fairly large step. Just loading the movies, for example, needs 1.4 GB of spare RAM, which is not much, and about 15 seconds. Once we load the movies, what I did was shrunk the data to include only movies. Actually, IMDb has data also for TV series, videos, and so on. So now that the data has been shrunk for the movies, we just have all the titles for movies. Second step was, who are the actors? So for this, I loaded the title principals relationship and then filtered it out, saying, give me only the actors. I don't want the directors, composers, and all of that. That shrinks the data by about 40%. And I also want only those actors who've acted in movies, not actors who've acted only in TV series or videos and so on. So with that, we now have the titles of the movies, the names of the actors, and the relation, whether it's an actor or an actress. And finally, we load the names of the people themselves. and then drop anyone who has not acted in movies. Having loaded all of this, the next step is to see how we can figure out the shortest path. And for that, the network X library comes in handy. If there are people here taking notes on what you might want to note down technically, point number one, network X can help you find the shortest path between two nodes. So the way network X works is you can read from a pandas edge list. Now, what is an edge list? An edge list is something like this that says this particular entity is connected to this particular entity. This particular title is connected to this particular name. There may be some relationships additionally, but it just requires these two things. And it creates a graph out of it, and it's a pretty efficient function. Within that, it has a function called shortest path. So we take this graph that it's created and then say, give me the shortest path between some two actors. Now, these numbers represent Robin Williams and Angelina Jolie. So what is the shortest path between Robin Williams and Angelina Jolie? It says this particular name, that is Robin Williams, connects to this particular movie. I have no idea what this is, which connects to some actor, which connects to some title, which connects to the last one is Angelina Jolie again, which doesn't really make sense. So let's write a small utility function that prints it in English. So now the shortest path between Robin Williams and Angelina Jolie is Robin Williams to Dead Poets Society, where he's acted with Ethan Hawke, who's acted in Taking Lives with Angelina Jolie. So that's the path that connects these two. And now we can start connecting pretty much anyone, right? So, and it turns out that this is not the only path between Robin Williams and Angelina Jolie. You can also go via Robert De Niro with 2 films, or Matt Damon, or Dustin Hoffman, or a whole bunch of other people. Now, given this, we can start exploring the network. But before we do that, I'd actually like you to suggest how we could explore the network. Open question to the audience, and sure, I request your help to get audience feedback. Can you tell me any 2 actors that you would like to see the connection between? Let's find out which 2 actors are connected. Just pick any 2 actors anywhere in the world, India, outside India, Hollywood, Bollywood, Iranian films, for all I care. Sorry, somebody and Brad Pitt. Who and
Mithun and Brad Pitt.
Sorry, say that again.
Mithun Chakravarti.
Oh, Mithun Chakravarti. Okay, how do you spell Mithun Chakravarti? Let's see. Mithun Chakravarti. Okay, let's assume that that's the spelling. Mithun Chakravarti. I've got to spell this exactly the way IMDb does. And Angelina Jolie, I can copy the spelling. So, okay, what's your guess? How many people, and maybe somebody could just do a count in the audience or remotely. How many people think they're directly connected? Option A. How many people think they're connected by one link? That's option B. How many people think they're connected by 2 links? Option C. So just say A, B, or C, or maybe do a show of hands. Okay, I see some from the chat window.
Direct link A, no hands raised. One hop. Okay, 1, 2, 3. This is out of about 50 odd people.
Okay, 3
4.
Wow, okay.
4 out of 50.
And most people, I guess, are saying 2 hops. So there are 2
hops, and also I hear a prompt in the room that at least 4 hops.
No, the movie world is a hell of a lot more tightly connected than that, I bet. But okay, let's see. I might place my bet on just 1 hop, option B, between them. Let's see. I haven't done this before. So let's run this and see what this is. Okay, hold on. Did my notebook just completely crash and I don't even have this running? Ooh, okay. What am I supposed to do now? This is the trouble with live demos. It's running. Okay, path's not defined. Sorry, looks like my notebook crashed. So we are going to be in a bit of a mystery for a few minutes. What I'm going to do is have the notebook run up to this point and then figure out the answer to this question. So how do we run everything up to this cell? Great. And I'm going to continue. And once this is done, you will Well, we'll see the answer, but let's stay with a bit of mystery on that for a bit. So I was exploring a few others, like Iranian actor Shahab Hosseini to Angelina Jolie. It turns out that there are two people between them, and it turns out that Shahab Hosseini also needs to connect to Irfan Khan, possibly, or Clive Owen or Morgan Freeman to connect to Angelina Jolie. What about the comedians Robin Williams and Jackie Chan? Turns out that there are only 4 ways they can connect between them, either through Dustin Hoffman, Max von Sydow, or Owen Wilson. There are 2 paths there. The 2 highest paid actors in Asia, Rajnikant and Jackie Chan, they have only one connection, Winston Chow, who has acted in Kabali as well as 1911 with the 2 respective actors. Another interesting and curious one was the Clint Eastwood star. The original. Okay, so Clint Eastwood has starred in films that were originally played by Toshiro Mifune, the Japanese actor. So Akira Kurosawa directed a whole series of samurai films, which were then played by Clint Eastwood. And it turns out that he has a couple of connections, second-order connections, via Lee Marvin and James Garner to them. And by now you've probably seen that 2 connections is about or 2 hops is the largest that we've seen so far. One of my friends at The Hindu said, look, take the South Indian actor Sivakarthikeyan and Kevin Bacon. Kevin Bacon is supposed to be extremely well connected. How far does this Sivakarthikeyan from him, who probably hasn't acted in any movie outside of classic rustic Tamil films? And even then, it's only 2 hops. Brendan Fraser has acted with Kevin Bacon, Abhay Deol has acted with Brendan Fraser, and Sivakarthikeyan just needs to connect to him. Then he picked a really tough actor. So I don't know how many of you have seen The Gods Must Be Crazy. There's an actor who's actually a bushman, whose name I can't pronounce, but it's spelled !XAU. I have no idea how to call him, so I'm going to call him Chow. And has he acted with Ashish Vidyarthi? It turns out that through Mithun Chakravarti, who has acted in Chandni Chowk to China with Chia Hui Lee, who's acted with Lung Chang in Crazy Safari, it's still only a 3 hop. That is Ashish Vidyarthi to actor 1, actor 2, actor 3 still gets you to Ming Shao. And no more than that. So are there any actors that, this is truly the longest that I could find. This guy with Gandhimati. I don't know how many of you have seen Gandhimati in Tamil films, but it's safe to say that there are very few actors outside of Tamil films who have acted with her. So via Kamal Hassan, via Seema Biswas, via Don McKellar, via Pei Cheng, that's a 4th order connection. We actually get to her. So for those of you who believe that it'll be 4 connections, 4 steps between Mithun Chakravarti and Angelina Jolie, I think you're likely to be mistaken, but let's find out. We're running this step now. And dum-de-dum-de-dum. Okay, not bad. It turns out that we have to connect via Shabana Azmi and Rosaria Dawson. That's one possible. There are many ways, but it takes only 2 hops between them. So not option A, which is direct connection, not 1 hop, which I was guessing that there'd be just one movie where one actor who's co-starred with both of them, but several ways of getting there with 2 hops, including Irfan Khan. And yeah, I think it's mostly Irfan Khan. Well, now this actually leads us to many more explorations, right? It's not like we just have to look at 2 people. We can start exploring the structure of the entire cluster. And there is this tool called Kumu, KUMU.io, where you can take a network like this, upload it, and have it plot the entire structure of the network. So I did that, took the full set of actors across the world, uploaded it onto Kumu, and created a network. And this is going to take some time for it to appear on the screen. It's a really, really large network. It's the entire Internet Movie Database out there. But once it gets on the screen, you'll be able to discern some patterns, which we are going to go more into. But for those of you who are taking notes on what tips and tricks you can learn, a second one that you might want to make a note of is Kumu.io great for network visualizations. For those of you who can play around with D3 and create your own visuals, it's a great tool. For those of you who can't, Kumu.io is your next best option. So it's populating the entire universe of actors along with their connections, and you can see that it's forming clusters, very clear, distinct clusters. Right? So let me just pick any one of these actors. Sometimes this works, sometimes it doesn't. Let me pick. Okay, so that person I just clicked on is Shobhan Babu. And you can see his name on the left side. I think he's a Malayalam actor or a Kannada actor, but clearly somewhere in India. So you can see that this cluster that's in the bottom right is probably, well, certainly Indian films, probably South Indian films, because I see a nearby cluster that is kind of connected. It's got Birbal, who's a North Indian actor. So, okay, so that must be traditional Bollywood. And it has a few linkages, maybe Bangladeshi films and stuff like that. On the other hand, here's another reasonably remotely linked cluster. Nello Nayo. I have no idea who he or she is. So, Nello Nayo. Let's find out. Nello is, okay, what language is this? Known for some film. Okay, this is where Wikipedia comes in handy. If we can find him or her on Wikipedia. No, but okay. Yeah, I have no idea what. Does anyone have any idea what language this is? And if so, please just put it on the chat window. I'll have learned something new today, thanks to you. But just glancing through it, I'm still not okay. Possibly Philippine, because he or she seems to be featured on a Philippine list. Yeah, looks Filipino. And there's something pretty interesting about the Filipino cluster that I'll come back to in a short while. But you can see some diffuse clusters. You can see some clusters that are connected to each other by very few actors. And it's all fine to look at this and try and make sense out of it. But wouldn't it be nice if rather than having to do this visually, there were an algorithm that allowed us to identify what these clusters are and name them? So that's what we're going to look at next. How can we use algorithms to figure out what clusters look like? For this, you need scikit network, which, well, it's not the only thing that you can use, but scikit network is a pretty effective way of clustering networks. Again, for the note takers, scikit network has a sub-package called sknetwork.clustering, which is what we are going to be using to cluster networks. And there are a number of clustering algorithms. What we'll do is take a look at the clustering algorithms in terms of how they behave. So imagine that we have 4 different clusters. Cluster 1 is where actor A is connected to actor B, actor C is connected to actor D. But A and C, B and D are not connected or anything. These are 2 disjoint networks. Let's assume that, imagine that that's one scenario. In another scenario, the top 2 actors and the bottom 2 actors are tightly connected. They've acted together in lots of films. But the actors on the right have acted together in only one film. Now, in the first case, we expect 2 clusters. In the second case, you may say, well, maybe you could treat them as 2 clusters, or you could say all of it is one cluster. Both are reasonable outcomes. On the bottom left, we have the top 2 actors having acted in one film, the bottom 2 actors having acted in one film, but the 2 right actors have acted together in many films. So at least these 2 should be in the same cluster. Whether the other 2 are part of the same cluster or different clusters is an open one. And similarly, we have the top 2 actors tightly connected, and then the actors on the right are connected by one film, and the actors at the bottom are connected by one film. So what we're going to do is take these 4 scenarios and apply the different clustering algorithms and see what makes sense. And at the end, you may be surprised at the result. But the first algorithm that we're going to explore is Lovain. Now, Lovain creates 2 clusters, the one in blue and the one in orange. The first makes sense. The 2 people on top are acting together often. The 2 at the bottom are acting together often. There are no connections between. Makes sense. The one on the top right also makes sense. Top 2 actors are working together, bottom 2 actors are working together, and it has decided not to connect these 2 clusters with just one pair of actors having acted once, which is a reasonable, valid result. On the bottom left, it has decided that there is only one cluster. The two actors on the right have acted in many films together. They definitely form the same cluster, but because they've acted with one film each with the actors on the left, it's decided to connect them also. Fine, no harm. And on the bottom right, the two actors on top have acted together a lot. Connect them, fair. Actors at the bottom have acted only once, it has still decided to connect them. Okay, nothing wrong. And it has decided not to connect the two on the right. Okay, debatable, but you could argue it either way. So overall, and I tried various combinations with Lovain. I couldn't find anything wrong as such with Lovain. I may disagree on the margin, but nothing wrong. On the other hand, propagation clustering didn't make much sense. Propagation clustering basically says if two actors have acted together in even one movie, they're one cluster. So which means that it's good only for identifying completely disjoint clusters. So if there is just one single film that, well, okay, basically think of it this way. It'll say that Gandhimati is a Hollywood actress because she's acted with someone who's acted with someone who's acted with someone who's acted with someone who's acted with Angelina Jolie. Makes no sense. K-means makes even less sense. I have no idea what it's trying to do. It decided that these two people who have acted together in 9 movies are different clusters, but these two people who have acted together in 9 movies are the same cluster. I gave up. Paris, another clustering algorithm that doesn't make too much sense. For whatever reason, it just decided that the bottom two actors are always connected no matter what the relationships are between them. Lovain hierarchy, again, has similar problems. It really doesn't have too much meaning. Ward also, it decides the bottom two are one cluster, the top two are not one cluster, even though there's absolutely no difference between these. So short summary, if you're applying network clustering and want something that is reasonably intuitive, I haven't found anything better than the Lovain algorithm. That does not mean that these do not have validity. There are specific instances where these algorithms are relevant, but for the vast majority of the kinds of data that I've been looking at, they don't really make much sense. And I'll explain what I mean by the kinds of data. Now, again, we download all of the data, identify the actors, blah, blah, blah. I'm going to skip the stuff that we've already done before and go straight into the clustering structure. So now what we have is the same structure as before, the actors and the movies that they're connected in with some additional information. But what we need to do is convert it into an adjacency matrix. So this is a subset of that adjacency matrix where each row is a movie and each column is an actor, and the cell has 1 if that movie has that actor. It's 0 if they are not. So it turns out that for the first 10 actors in the first 10 movies, they're all 0 because the first 10 actors have not acted in the first 10 movies. But from here, how do you get to an actor-actor cluster? And this is where the beauty of linear algebra and matrices come in. It turns out that if you multiply this matrix by itself, square the matrix effectively, well, technically with its transpose, you will get a matrix where the rows are actors and the columns are actors. And the values are the number of times they've acted together, the number of films effectively. So what this is saying is that actor number 1 has acted with actor number 0, 1, 2, 3, 4, 5, actor number 5 once, and actor number 6 4 times. I'm guessing that this is Lauren Bacall acting with, I don't know who the second actor is. We'll have to figure that out. Now, this is what we feed into an algorithm like, where's my, okay, I'm going to skip all of the preparatory code, but this is what we effectively feed into the clustering algorithm. But before we go into the clustering algorithm, let's just take a look at which actors have acted together a lot. So if we say, get me the pairs of actors, it turns out that there are some actors like Bahadur and Adur Basi who've acted together in 192 films. That's crazy. 192 films, these two actors have acted together. The next record is held by Matsunosuke Ono and Kijaku Otani, Japanese actors who are, well, as you can guess from their birth year, pretty old actors, and they've acted together in 146 films, and beyond that just falls off pretty flat. Adur Basi with Jai Bharti in 127 films, which is nothing to be laughed at, by the way. It's just acting in 100 films is huge, and they've acted together in 100 films and so on. But these two Adur Basi and Bahadur, almost 200 films that they've appeared in together. Now, before we cluster, let me tell you what is perhaps the trickiest problem in any kind of clustering exercise, whether it's network clustering or just regular clustering. It's how do you understand these clusters? And arguably, the best way of understanding something is to name them something intuitive. That's how we identify people, that's how we identify stereotypes. Naming words is how we identify any concept. So we need to name clusters. And having explored this a fair bit, one fairly robust way of naming clusters is this. What you can do is label one actor, let's say Brad Pitt. You say Brad Pitt is American. Then the entire cluster that Brad Pitt is in is possibly American. And if we have a dozen actors, all of which are labeled American, and that cluster has mostly these actors, then you can say the entire cluster is American. So you don't necessarily need to label the entire cluster at one shot. You can instead name a few entities and then guess the name of the cluster based on the common names or common tags. And these become important. It's important to have tags, not just a tag, because take Ingrid Bergman. Ingrid Bergman has acted in Swedish films and in American films. Javier Bardem has acted in Spanish films and in American films. So you've got to tag them as both. And not just cross-cluster, but sub-clusters also. Now, if you want to sub-cluster Indian films, you get Telugu films, Bengali films, North Indian films, South Indian films. So somebody like Brahmanandam would have to be tagged in the Telugu sub-cluster of the South Indian cluster. Anup Kumar would have to be tagged in the Bengali subcluster and the North Indian cluster. So part of what we did was took actors. So Archie Manorama is an Indian, South Indian, Tamil actor. Alekos Alexandrakis, and I picked reasonably famous actors in those languages, is a Greek actor. Cary Grant is an American actor, but also I've got another category called old, because it turns out that some actors are just separated not by language, but rather by the decade or the era that they worked in, and so on. Now, given this, we can actually start clustering. And I'm not going to go into the code for this. All of this, by the way, is on GitHub, and I'll share the link on GitHub where you can run these notebooks. But the crux of it is in, where do we have the actual? The crux of it is this one, where we take sknetwork.clustering.Louvain, where, I've put in a fixed random state so that it's repeatable. And then we pass an adjacency matrix. The adjacency matrix has rows as actors, columns as actors, and the number of times they've acted together. And that's what gets passed into the model. It doesn't take too long, about a minute max, or maybe less than a minute. Now, let's start looking at what kinds of data we can get out of these clusters. I'm going to zoom out a bit so you can see this. So this is the result of the clustering, which says that this actor belongs to cluster number 10. Now, what exactly is cluster number 10? Who knows? But we have named these actors, right? So in cluster number 10, it turns out that there are primarily actors who have been labeled as Indian, labeled as South Indian. We also have actors labeled as Tamil, Old, Telugu, Malayalam. So it broadly looks like cluster 10 is best described as the Indian, specifically South Indian actors. And Bahadur belongs to this cluster, because you can see that this cluster has all kinds of South Indian languages. Same for Adur Basi, lots of South Indian languages. Matsunosuke Ono, clearly Japanese. This cluster has actors who only be labeled Japanese. Jayabharati, Indian, South Indian. Terta Sariko, Finnish and Old. Bernard Bosick, Hollywood porno, and so on. So now we not only get this cluster, which is the easy part, but also what we might characterize this cluster as, which is the hard part. Now let's see what we can learn from these. I'm going to skip all the code and jump straight to what we can get from this. So it turns out that there is a long tail of actor clusters. If you look at the largest cluster, it's probably best called Hollywood. It contains American, British, German, Spanish, and French actors, 84,000 of them. And here are the most popular actors. Many of them are old actors, because when I say popular, I mean they've acted in a large number of movies, and people used to act in many more movies than they do today. The second largest cluster is best described as Hollywood horror. And I would never recognize any of these names. You know by now my fear of horror films. The third cluster has two languages, Italian and Spanish. The fourth cluster is probably best described as Old American. It also has a few Swedish, British actors. John Wayne is perhaps one of the more famous names on this list. Lionel Barrymore, for those who go back a generation, you might recognize these. There are Old German, that's one cluster. Chinese actors, that's another cluster. The Indian actors, specifically the North Indian ones, that's another cluster. Beginning with Mithun Chakrabarti, who's the most prolific of the lot, followed by Shakti Kapoor. Japanese, Russian, Mexican, South Indian, with Brahmanandam being the most prolific of the lot, followed by Adur Basi, and so on. Hollywood porno is a cluster of its own, as distinct as language. So you can see by now that there are three dimensions on which clusters happen. Language is clearly primary, and age of the film is secondary, old films versus new films. But genre, specifically porno, is a completely different cluster, and you'll find actually how distinct they are. Japanese porno is another example of such a cluster. Now, we have all of these clusters, but before I go on, there's one thing that I wanted to just touch upon, which is, look, we've been talking about movies so far, and I did promise you that whether or not you learn anything about networks, you will learn about movies. But all of the exploration that we've done, the principles apply to a huge number of fields. And I want to spend a few minutes talking about the fields that it does apply to. Product networks. So let's say, okay, I don't know how to make it bigger. Sorry, give me a second. Okay, here we go. Product buyer networks. So just like you have movie actor networks, you could take products like movies and buyers like individuals and start clustering the products based on how often they're bought together. Same principle. That helps you recommend similar products to others. Or you can cluster the buyers based on how often they buy the same product, right? So that allows you to take a group of buyers with similar buying preference and market together to them. What I mentioned for products also applies for auctions, by the way. So same principle goes there. Another is financial networks. So is a person a director of a company? If so, then you can start looking at which are the companies that have common directors. And if there is a company that you're investigating for fraud, then start investigating the other companies in that cluster for fraud as well. Or common directors. Are there directors who are common across companies? Because then you have a network of directors, and if you want to invite somebody for a board into a board, then you can just look within the same cluster for people who are looking at. You can look at other people to invite to your board. Basically, payment networks are another. People and transaction. So you can look at how often people pay each other. This could work with either a UPI kind of a system or within Flipkart, the kind of transactions that people make, buyer to seller specifically. Are there some buyers who are specifically working with specific sellers, which is great for money laundering and fraud detection. Person email networks are there clusters of people based on how often they are writing to each other on email or sending calendar invites to each other or part of the same mailing list or WhatsApp groups. Companies, patents, authors. That's great to find out whether a competition is working on some new innovation, what kind of people to hire who have patents, what are your competitors doing. Authorship networks, senators and the bills that they've passed, people on Stack Overflow, are they talking about a given topic and what topics are related? I could go on. We'll never be able to complete the set of bipartite networks. And the interesting thing is that none of this requires any quantitative information. And what quantitative information did we get from IMDb? We created those relationships. So if you have two columns that are text and they're kind of repeating, then you have this kind of data. Now, this exploration goes on for long, but I'm going to end with just one example of the kind of thing that you can do with these clusters. One question that we can answer is, which are the most insular or liberal clusters? We saw a whole bunch of clusters, right? Iranian films, Turkish films, North Indian films, British films, Hollywood, and so on. Which of these clusters work with other clusters? So now we are not talking just about networks of actors. We're talking about the networks of clusters themselves. And it turns out that you can start looking at the collaborations between these. So for example, let's take something, let's take Chinese films. So it turns out that Chinese actors, the Chinese cluster, acts within the Chinese cluster 98.2% of the time. That's quite a lot. So it's only like 1.8% of the acting that Chinese actors do is with non-Chinese actors. Specifically, they work with Hollywood 0.5% of the time, Japanese 0.3% of the time, South Korean 0.3% of the time, and so on. So a quick check. Here's a poll from everyone, both in the room and online. Which cluster do you think is the most insular? And I'll give you a quick view of the top 10, 15 clusters, but you don't have to limit yourself to this. I'll keep scrolling gently so you can see it, but just feel free to type. Which of these clusters do you think is the most insular? That is, they act only with themselves. Just feel free to type in your answer or share the response.
Yeah, people who are online, they can type on the chat, or in the room if there is any response, I can amplify that.
Russian, okay.
North Korea.
North Korea. Oh, okay. I didn't see North Korea at all on this list. I saw South Korea. So you may be right, but I haven't seen North Korean actors. Period. Few people are saying Russian. Okay.
Any other response in the room? No. On the chat there is one. Oh, two. Russian.
Okay, fine. Seems to be the consensus. Well, let's find out. So this is set of the top 30 clusters. Let's look at how they get connected. How do I? It's got to be some way of moving this so that here I can move it. Cool. Now, Hollywood. Let me reload this. They're supposed to get highlighted. Okay. Yeah. Hollywood acts with British actors the most. They're pretty tightly connected. Hollywood television actors, they're also reasonably connected to mainstream Hollywood. Hollywood horror is reasonably well connected with Hollywood. Old French actors, and we can keep going, expanding the network. But the first cluster that we see that's not Hollywood is the Japanese and the Japanese porn cluster. Hollywood is a completely distinct cluster. Let's keep going. Italian connects to Hollywood. And now we have the third cluster that's independent of these, North Indian and South Indian cluster. Old American connects to the Hollywood network. Italian connects with the Old French network. Old German comes into the mix. Yugoslavian comes into the mix. Old Czech is indirectly connected. Old American, Spanish, Mexican, Polish. They're all adding to the big Hollywood nexus. But nothing outside of this is getting connected until, Spanish, Mexican, Brazilian, it's kind of extending the Hollywood network again. Chinese and South Korean are closely connected. And you'll notice that now we have four major groups. The Hollywood group, which is the largest, the Indian, and the Chinese / South Korean clusters. Let's see what gets connected. All getting connected. Now you see the European and Eastern European films are getting connected to Hollywood. Russian is now getting connected to Hollywood. So those who guessed Russia, yes, you're right. It's pretty isolated, but not as isolated as Indonesian, Greek, Turkish, Hollywood porn. Now this is interesting, right? It's actually tougher to act with a Hollywood actor if you're in the Hollywood porn business than if you're Brazilian or Russian. Even that is easier. It's only now that Hollywood porn actually starts connecting to Hollywood. So it's like a sharp divide there. Hollywood keeps expanding and interconnecting. Greek and Egyptian movies get absorbed, keeps going. But now we see that Iranian, Turkish, Indonesian, and Filipino left in the lurch. And these isolated clusters still remain. Indonesian now connects to Chinese. They form a link, so that expands another. Iranian and Turkish form a link, which leaves Filipinos. Oops, where did that go? Okay, which leaves Filipinos. That's a bit of a problem. Okay. Some of these back. Yeah. As Filipinos as the one cluster that is crazily isolated. And when you look at the numbers, you'll figure it out. But I'll keep expanding this. Now the Chinese start connecting with Hollywood. Filipinos are still isolated. The Japanese start connecting with South Korean. The Filipinos are still isolated. Let's hold the Filipinos here, North Indians here. So Iranian Turkish cluster still remains separate, but now you have one major cluster in Hollywood. The cluster keeps tightening itself, and eventually, after a lot of connections, you finally have the North Indian cluster connecting with British films. But Iranian Turkish is isolated, Filipinos are still isolated. And finally, the Iranian and Turkish cluster gets connected to Hollywood with 0.2% of the people acting together, and Filipinos are still untouched until we get to a level of 0.19%, which means that roughly 2 out of every 1,000 times that a Filipino actor acts, they act outside of Filipino films. That's how isolated this cluster is. Now, let me pause here. And I know we've talked a lot about films, but there is one thing that I wanted to touch upon, which is what you can take away from this. See, the thing is, networks are one of those highly, extremely understudied fields. It's not easy to analyze them. It's not like we have the tools. Anything quantitative, you can hit it for a boundary. Text is increasingly becoming more and more analyzed. And the instant you start analyzing text, you invariably find some insight because nobody's analyzed it to any great level of detail. Geospatial is another one of those fields. Very few people have done geospatial analysis. The third boundary that I see like that is network data. It's like if you just apply your mind to it and start scratching the surface on any kind of network analysis on relationship data, you will find something that is not just surprising and unknown, but also extremely powerful. I'm not saying that this will be the first kind of result that you'll get, but it doesn't take long to dig deep and come up with something that's surprising and powerful. So I hope what you've taken away is, apart from all the film gyan, three things. One, among other things, you can find the shortest distance between clusters. Between entities, and that can be useful to find out how far or similar or distant they are. You can identify what the clusters are in any network and name them in a clever way, which is pretty powerful. Third, you can also find the interaction and the relationship between clusters. We haven't gone into a large number of other questions that can be answered from this, but you will see all of those on the GitHub repo and in the Jupyter notebooks out there. So feel free, and they're all exploring the movie network. But my ask is just one. Take any of the use cases that you saw or any of the use cases that you can think of and try applying these analyses to that data set. You're bound to find something really powerful. With that, thank you very much. You've been a very patient audience, and I'd love to take any questions that you may have.
Okay, let's first hear a round of applause for Anand for this very interesting talk.
Thank you.
Hello. Yeah, Anand, this is one of the most hands-on, interactive keynote talk I have ever seen. Really, really thank you. Oh, this is wonderful. Is there any question in the room first? Let me just check in the room and then I'll go online. And if, Auditro, if you could monitor if there is any question on the chat. Okay, there is one question here in the room. Anand, if you could just introduce you by your name and just a quick one line what you do, that would be great before you ask the question.
Sure. Hi, I am Sudhanshu Singh and I am part of the NLP team here. I'm just curious about that hops thing that you were talking about with the actors network. So did you do all node pairs shortest path and look at the distribution, like maybe 90% of the pairs and always connect in two hops or something?
Oh, sorry. When you said hops, I'm sorry, I misheard. My apologies. I thought you meant Hobbes in Calvin and Hobbes.
No,
so
Hobbes,
you just gave me an idea, thanks to the miscommunication, which is I haven't done a network analysis on Calvin and Hobbes, which I mean to. But my apologies then. Sorry, because of that, I misinterpreted your question. Could you repeat?
Yeah. So did you do an analysis on all pair shortest paths that, formally we can say that 90% of all the pairs of actors are connected by two hops or something?
Ah, I see. Okay. No, that's actually relatively easy to do because what we can do is take the total number of connections and see that as a fraction of. And now comes the question, what do we take this as a fraction of? Right. Now, one possibility is to say every pair of actors could potentially be directly connected, and we could take that as a fraction. And in that case, it turns out to be a tiny number, like less than 0.1%. But the question then becomes, what kind of useful metric can we get out of the fraction of connections? In other words, can we figure out if there is a density of the connections? And it turns out that there is a measure called modularity, which I have used of a cluster. Let me share. This is in one of the notebooks. Okay, yeah. So I'm putting out here a metric. So whenever we cluster, the algorithm gives us a measure of modularity, which is percentage of links within the cluster versus percentage of links if the pairs if the actors were paired randomly. So what it does is randomly connects pairs and then looks at the actual result and sees what percentage of the links between actors are within the same cluster versus if they were clustered randomly. Now that is modularity. If it is 100%, then it means that we've created clusters perfectly. All the actors are acting only within the cluster. No actors are acting across clusters. On the other hand, if it's something like 30% or 40%, then we've got a terrible cluster, and 50% or above is a reasonably good one. Now, this isn't really about the density of links in a network, but I haven't found a strong meaning or usefulness in many of the use cases for the density of the network because I didn't really have much to compare it with. But modularity is a fairly close one where it compares with the random connections, and that is a slightly more useful measure. When I took clusters and then did subclusters, so I took Bollywood and then said within Bollywood, what are the clusters? And it turns out that there's Marathi, Bengali, blah, blah, blah. Well, not Bollywood, really, North Indian. And then within Hindi films, what are the subclusters? You can broadly say there is the Irfan Khan subcluster, there is the Major Khan subcluster, there is a bunch of others, parallel films, Tapsi Pannu and a bunch of others, and Ayushmann Khurrana and what's her name, Bhumi Pednekar, they form another subcluster. So in all of these cases, the modularity starts decreasing. It's not like they are completely isolated from mainstream Bollywood. They are acting a lot with Bollywood, but they do form a cluster on their own. Short answer, cluster density could be a meaningful measure, but modularity seems to be a more relevant one that I've found so far.
Yeah, one more question here.
Hi, this is Nikesh. Very interesting talk. Thank you. I was wondering, when we look at these shortest paths, right? In real world applications, it may be actually better to take a longer path depending on the strength of the connection, right? So have you explored that, right, in your analysis?
No, but I see your point, and that's an interesting one. So what you're saying is, rather than look at A to B to C if they have only one connection, can I go A to B to C to D if they've acted in, let's say, 10 movies each? No, obviously, that's a much closer one. I don't, off the top of my head, know of a metric or an algorithm that does that, but that is super interesting. So I'm definitely going to explore that. Thank you for that, Nikhil.
Anand, I have a question, a little high level and might be a bit provocative. One of the things that I have seen, like in industrial, or you might have also seen that industrial use cases are much more in nature, or industrial application of machine learning is much more supervised, classification, regression, and those use cases are much more common than clustering or network analysis and so on. Is it because that the clustering and network analysis are good for more exploration rather than actioning or automation and things of that nature, which are more common in the industry in this world, or is it something else, or you may not agree completely? That's also fine.
No. I do agree that we haven't discovered how best to action clustering or any unsupervised technique, but clustering is perhaps the best example. And here I'm talking about network clustering, which is like pretty niche, right? I mean, even regular clustering, people find it hard. But personally, I've been exploring clustering for a long time now in great detail. And I find that here's where people get stuck. They create the clusters, that's easy. Now what? So actor one is in cluster 10. Okay. What am I supposed to do with it? Supervised, at least there is a metric that I'm trying to optimize. Here, what am I trying to do? Now, with a certain amount of thought, what to do is easily derivable. For example, we were working with the Singapore Health Promotion Board. They said, we want to cluster the citizens based on their health activity. What kind of food they're eating? What kind of exercise are they doing? Demographic characteristics, physical characteristics, and so on. So that we can market to each of these people differently by identifying what are that segment's common needs. Or take Dubai tourism. They said, we want to understand the spend patterns of our visitors. And then for each of these segments, find out what kind of marketing we need to do that is different. So this looks like an obvious and emergent use case, which is segment and then give them what they need that is missing. But the trouble is, people get stuck at the point where we try and describe these clusters. How do you name a cluster? How do you characterize them is becoming the toughest problem. That's where I see our team just completely get stopped, our clients get stopped. And we've been working on this for quite some time on tools that, and that's a completely separate talk. I'd be happy to do that anytime, but building tools and techniques that will help people characterize clusters. You saw one of that a short while ago, which is tag a person and then use that to tag the cluster. That works for network clusters. For quantitative clusters, what you really need is take a series of characteristics, find out which of these characteristics is unusual about a given cluster. So then you can say, oh, these are the people that are spending on watches in the airport. These are the people who are collecting so many points, health points from the store that is humanly impossible. So they are collecting from the trash can and therefore are cheating the system. So call them the cheaters. And these are real life examples of names of clusters that we created. Short answer, I think unsupervised analysis is less useful than supervised analysis in terms of the total number of use cases. But in terms of potential, we have discovered a lot less with unsupervised analysis. And therefore, I think there is a little more bang for the buck there.
Sure, makes sense. Thank you, Anand. Is there any other question? Maybe one last question in the room? Okay. Looks like there isn't any more question, Anand. So on behalf of Flipkart, I would like to really thank you one more time. Really appreciate this interesting talk and spending the time with us. Thank you very much, Anand.
So glad. Thanks, everyone.